Very recently, Stephen and I and a huge group of people at Pivotal and AxonIQ and Solstice all worked together on a reference architecture for CQRS and event sourcing, which is open source. You can find all the source code online. It contains a reference implementation, if you like, of CQRS and event sourcing. It's built on Spring Boot. And it uses quite extensively the Axon Framework, which is something that we'll hopefully show you today. And it's hosted and developed on top of Pivotal Cloud Foundry. So we use Pivotal Web Services for this. If you would like more information about that, then you can find it here at axontrader.cfapps.io. And if you go there, you will see something like this screen over on the right-hand side there, which tells you all about the trader. It's a faux stock trading application, so you can use it to pretend to trade stocks in companies. And it also contains links to the GitHub repo and all the source code. And what we thought we would do today is tell you a little bit more about how we built it, and we'll hopefully do that with a demonstration later.
Definitely.
Okay.
Yeah.
So quickly moving on. So has anybody here not heard of Spring Boot? Excellent. Okay, that's good. So I'll skip that one. So we're going to talk about Axon Framework. So Axon Framework is an open source, Apache licensed Java framework. It gives you first-class support for CQRS and event sourcing, and it made it really easy for us to build our reference architecture. So it contains support for things like aggregates and aggregate routes, commands, queries, and event sourcing, and even does things like sagas as well. And it really helps on focusing on the business logic of your application. It gives you a nice, clean abstraction in which you can work, right?
Definitely, yeah.
So, so we're going to show you some of that in a moment. And we're also using Pivotal Cloud Foundry. So the fastest, most productive way to get into production is to have some sort of platform, and we use Cloud Foundry for that. So it's essentially the premier platform for developer productivity. It's fully polyglot. It's got a marketplace of services, which we hope to show you as well. And it's very automatable, and it allows you to deploy your applications thousands of times a month. And indeed, we did as we went through that process.
Yes,
right? So more information available on that online as well. You can go and have a look at it at run.pivotal.io. Anyone can sign up for Pivotal Web Services, and you could use them today. So maybe if you like it, give it a try.
Definitely.
So,
yes.
Over to you.
Can you give me control? Thank you. Thanks for that, Ben, for starting it off.
No worries.
Ben was already sharing about the Axon Framework and that it helps you do CQRS and DDD and event-driven architecture. And I want to share a couple of those concepts so that you don't blindly dumped into the live coding session we're going to start in a couple. So we're going to start with the seekeresbit. So what is it? So it stands for Command Query Responsibility Segregation, and I think that acronym already explains a lot what it is. It's separating the responsibility of your command and your query side in your application. So you could imagine that a little like this, that you have a client or a UI, a thing which works with your application, and you can imagine like two clouds in your system. So there's one cloud on the left dealing with the domain logic, with dealing with the commands, so the part which receives a command, so the expression of intent to handle a certain action, and that part makes the decision-making logic. So it decides whether a certain action is okay to do, to make a state change, whether that's okay or not to do. For that, it'll only need the data which is necessary to make that decision. That's all the information you'd have on your command model. On the right side, we have our queries, our projections. So that side is meant to answer the queries you have, so deliver the data as it's needed to your client. So you have your information, your projections as a table per view or denormalized, so just to answer the queries as quickly as possible so that you're faster on that side of the equation. So sweet, we got our command and a query side dealing with your application, but we need a way, they're still part of the same application, so we need to synchronize the data within that respect. And I think a very nice way to do that is by having events. So our command model makes a decision, and if the decision is made, it propagates that through the system via an event message saying this has happened. That event is then used to source itself, to change its own state, but it's also used on the query side of things to change the query model, to update it on that respect of the view. So we now really have an application which deals with commands, queries, and events. And I think the events bit brings us to a very nice other concept to talk about, being event sourcing. So to explain what it is very shortly, it's rather than storing the entire state as it is, you store the deltas, the state changes would happen in your application, and that's it. So fair, what does it look like? I think an example is very nice of that. So here on the left we have a CRUD, or a state way of storing it, and our example is a virtual wallet we have. So we have your state stored wallet with an ID. I'm the owner of that wallet. Apparently I've got 1,000 euros. Success, kind of nice. But what would this look like when you're doing event sourcing? It would be quite a little different than that. So there's a point where the wallet is created. So we have a wallet created event, the state change that has happened. And we see that with a couple of deposits, withdraw and another deposit again. So this is a different way of maintaining your state in your application than on the CRUD approach. And there are a couple of pros and cons you can see from this, I think. So one is that you have less data loss on the right side in event sourcing. And what I mean with this, on the left you see the end balance. You see that I have 1,000 euros. But you do not see how I ended up at that 1,000 euros. On the right side though, you see that there's a deposit, then we've got a couple of withdrawals and another deposit again. So we've got more information on the right. Another one is that you have an immediate audit log out of the box here. You see that we have a deposit, a withdrawal, another deposit. So you see all the things which have happened in our application, right? Yeah. Gives us a bit more. And there's also a slight performance increase because you're just storing the delta, just the change, not the entire state of your application at once. Does that change? So it should be somewhat faster. This, I already pointed out that we're doing commands, queries, and events. So this quite nicely brings me to the next topic, is that this is really a message-driven API you're working from. Those commands, events, and queries, those are the API which you deal with in your application and which you share with other applications to talk to yours. So there are a couple different ways of routing that stuff. So a command is really dealing with checking whether that decision, that state change can be made or not. So there's always a single point in your system which is the authoritative unit which can answer that decision or not. So it's going to a single point in your world. On the other side, we have queries. And a query is a different way of routing information because a query can be answered by Ben. If I'd ask your age, you'd probably be the authoritative unit to know that answer. But if all of us would go out for dinner and everybody, we need to know where to go, then I'd ask it to the whole group. So everybody can participate in answering that question. So there's a different way that you scatter and gather results in that format. And the last one on this side is events. And that's really that noting that something has happened and telling the world about it, that has happened. So that's really distributed to everybody.
Yeah, what I like about this is it's a real clean API. So you're always talking about either commands or queries and events. And in the way that you design the system as well, these things usually have different scaling requirements and different characteristics, right? As you said, the commands, they have a particular routing that's required for those. Similarly with queries, similarly with events. So you might get in an e-commerce system millions and millions and millions of queries, but very few commands happening. So correct. For example, if you build your applications in this way, you can scale them differently to if all that stuff was all bundled together, yes, as is the case with a traditional application.
Benefits in that world, yes. So I think this quite nicely brings us to actually showing some code, right?
Yeah, let's do it.
I got one minor message here. I forgot that. I really want to point out that an event and a message are not necessarily the same thing. All these three things you see here, the commands, queries, and events, those are all three messages. Event is just a more specific version of a message. It's a different way of routing, different way of thinking of what it is.
Okay.
Different reality. So this brings us to actually code some stuff.
So we're going to build a wallet, right? So yes. We talked about the wallet a moment ago, and we're going to essentially code up a CQRS event-sourced version of the wallet, right?
Yes, correct.
Okay, let's do it.
So let me open up IntelliJ for this. Is this readable at all? Yes, I assume so. If nobody's answering, it's not.
No, I saw some thumbs up. Thank you.
You saw some? Oh, yeah, great. Thanks for that.
That's great.
And we're doing this in the same format as we did our Axon Trader. So we're using Spring Boot. We're going to use Axon Framework, and we're going to push it to PCF eventually as well, right?
Yeah.
So as you can see, we got a very simple Spring Boot application. Not too exciting. Let me show some of the dependencies we have. Here you can see that we have the Axon Spring Boot starter, which makes it so just as any Spring Boot starter, you get all the required components from an Axon perspective in your application automatically, that you do not have to bother with that. Should be super quick. We also got data JPA because we're going to store some stuff. We're going to store a query model, some of our events as well. And we're going to do, we have started a web in here to actually access the application we're going to create through REST controllers, to be very fast about that. So now actually let's introduce some stuff. And as we showed with the previous slide, we have a message-driven API. So we're going to start off with our API. We're going to start with the messages in this respect. And as Ben and I are clean coders, we're going to do clean packaging in here. So I'm going to introduce a core API class. And I'm going to introduce a Kotlin file containing the wallet API, like so. I'm going to do Kotlin because it gives you a more concise way of creating my messages rather than having to write everything out, right?
Yeah, it's just quick pojos really, isn't it?
Yes.
It's really, really fast.
Yes. And I think the bit we should start with is actually the action, the state change we want to do. We want to create a wallet. So that's the thing we are going to create now. We're going to create a wallet command. So let's introduce that message, create a wallet command. And we need an identifier in that. I think that's fair. So wallet ID of type string. And we want to have a balance because a wallet has some money on it, like so. I'm going to add a final thing here. I'm going to make it the data class. Make so that we have an equals and a hash code and toString out of the box, which is quite nice for Axon things as well.
Yep.
And what would be other operations we could do on our wallet? We saw on our events, but
yeah, so we want to make deposits and make withdrawals, right?
yes, yes.
Okay.
So let's add actions for that as well. We want to make a deposit and a withdraw, so we make a deposit cache and the withdraw cache command. We're also going to make that a data class, the deposit cache command, and I'm going to reuse the fields I have in my wallet create wallet command because we're going to be quick and fast about this, and we're going to deposit an amount rather than a balance. We don't want to make it a temporal unit, and the withdraw is going to look quite similar. We want to target a certain wallet, so we have the wallet ID back in there, and we're going to withdraw an amount from our wallet.
So we're really describing the semantics of the API here, aren't we?
Yes.
We're saying exactly what commands we expect users to be able to give to us when they use this API.
These are the operations you can do on the wallet, and that's it.
Yeah.
These are all the things you can do. All the state changes, all the expressions of intent on the wallet you want to make. Now we also need to pair this with events because we want to change our command model in respect to the things which has happened, and we want to change our query model in respect to the changes which has happened. Mm-hmm. And we're going to be simple on this as well. So we're going to mirror this by creating events for that. So just going to copy it over, and I'm going to make them past tense because events are history. They have happened. So this is what they should be. Missed the command bit here. So actually make them events like so. And this brings us to, this is the API I'm happy with at this point.
Yeah,
I think
good.
we should proceed with actually creating our command model in the system. So let's go back over here. And as we are going to structure it neatly, because we want to pull it apart maybe in the future, we're going to introduce a separate command model package, which is really separated from the rest. So I'm going to call this command model. And I think a logical command model in this scenario is actually a wallet. So you can see it. Got a wallet, and I'm going to first introduce the first bit of Axon magic here. So I'm going to make this an aggregate. This is a D2D concept. I'm going to explain it very shortly. So what an aggregate is a group of entities which in regard to data changes act as a single unit. There's an aggregate group, which is the external reference to that aggregate, and there are applied consistency rules to that.
Okay.
Fair, right?
Yeah.
I think a real-world example also helps in this scenario. So what I think is a very simple thing to concept to think about is like a car. So a car consists of wheels and tires and windows. So it has several entities, but the aggregate is the car. There's also a single reference to that car, which, okay, my car has a massive dent in the door. So I know the car with the dent in the door, that's my car. But you typically do that through the license plate. That's the way to reference the car. Another thing, the consistency rules also apply if your car isn't broken, that is. Because if you turn the steering wheel, you expect your wheels to turn the right way. Right? So that's
they're linked and they're consistent.
Yes. Yeah.
Okay.
So let's not dwell on that too much.
Okay.
What this annotation does for Axon perspectives is that it makes an aggregate factory and a repository for it, so that it can be stored and created, and it will look for other things later on, which I'll explain. From Axon perspective, we need a default constructor, and we need a constructor to actually initialize this on the create wallet command. So we're gonna make this so. Got a command here, and we need another Axon thing here. We're going to annotate it with @command-handler. So this makes it so that Axon will check for this function because it's an aggregate. It knows this aggregate might have message handling functions, and it will register those to the right command buses or the event bus or the query bus. It does that for you. Now, this is typically in the command handler, we make a decision. We make a decision whether creation of this wallet is okay or not. And in this scenario, we're just going to publish an event. Just be simple about it. And the way to publish an event in Axon is to call the aggregate lifecycle, because we're in the lifecycle of a given aggregate. And we're going to apply an event, the wallet created event, because that's the decision we've made that this has been created. We give it the fields of the command, so the balance and the wallet ID, and that's it. Now, I already shared we need an external reference to this aggregate. And that needs to be state in this aggregate. So we need to add the wallet ID as state to the wallet. And since we're going to do event sourcing, because we're going to source our command model, our aggregate, based on the events which have been constituted by that aggregate, we're going to introduce an event sourcing handler, which is going to be like this. Real quick about it. Wallet created event. Here we see another annotation. So this is also an Axon thing. Again, similar as with the command handler, Axon will look for event sourcing handlers, register them to the event bus so that you get the events. But this is just for sourcing this wallet. So it will only receive the events this wallet has published, because it's only to recreate the state of the command model. So, and we're going to pull out the wallet ID as a field. So, like so, wallet ID. So, and make it a field. Yes, there we go. And we need to add another annotation here, because we need to tell Axon that this is the identifying bit for this wallet, for this aggregate. So we add the aggregate identifier annotation. So this is our basic thing. Now we need to introduce the other operations we can do on this wallet. So introduce a couple of more command handlers. So deposit cache command, like so. And we're going to be quick about it. So we're going to do aggregate lifecycle that apply, new cache deposited event. And we got the wallet ID as state at this point, because it's stored in the wallet, so we can grab it from its state. And the other bit is the amount we're going to get, like so. All right, and I'm going to do a similar thing for the withdraw. So let's copy that. Withdraw, cache withdrawn event. That's it. Okay, this is fair. We're not showing.
Oh, hang on. We probably shouldn't let people just withdraw willy-nilly, right? They shouldn't just be able to completely clear us out.
No, correct. No, we want to check that we at least have that they can extract the money which is on there, right? So we need to actually add some decision-making logic in the withdraw cache command. We need to check that there's enough balance on this wallet. So for that, we first need to introduce balance as an actual state in the aggregate.
Oh, of course.
Because we do not have that yet, right?
Right.
We're just publishing the event, and we didn't care prior to that. But now we do, because we need to check whether there's enough balance on it. Going to do event.getBalance, like so. Not remove the E there. And then introduce local variable, like so. Now it's a field. So now we got the balance, and we need to adjust the balance on the other event handlers as well. So we're going to do this, cache deposited event. I'm going to do balance becomes balance plus event.getAmount. And we're going to be pragmatic and copy this over as well for the withdraw. I'm going to do a minus. All right, that's a 0, Stephen. I'm going to do a minus. And now we can actually do a check on the withdraw cache, because now it's a field in this wallet. So we can pull out the command, because that's the state change we want to make. And we can check whether balance minus the amount isn't smaller than 0. And if it is, I think we should throw an exception, right?
Yeah,
because someone is trying to do something faulty.
So basically, you won't handle this command in the usual way if the funds aren't available. So you put in a decision logic in the command handler, right?
Yes, correct. Yeah, definitely correct.
Cool.
So we got the no funds available exception. I'm going to introduce this to the wallet API, because this is a thing we're going to propagate out to other people.
Yeah,
this might be a thing they will see. So we're going to add it to our Kotlin class. Going down, going to be very simple. This is the way to extend from something in Kotlin, the colon. So now we got our no funds available exception. Gonna fix this, add signature, great. So this is sweet, but we need a way to actually access this guy, right?
Yep.
So let's introduce a controller for this as well. So, oops, that's not what I wanted.
Oh, so we're just doing a regular REST controller Spring Boot styly.
Yes, yes.
Cool.
So the wallet, we're going to make this controller for commands, so a dedicated one. So here we go. And I actually live templated this because I want to be fast. You guys probably don't want to see me create a REST controller. It's not too interesting, right?
No,
so just a Spring annotation to make it a REST controller, request mapping on /command. And we're going to just initialize a wallet. Just be simple about this. So public void create wallet. All right, add this to the get mapping. And now we need a way to actually publish commands through Axon, right?
Oh,
so,
yeah, of course.
So for that, we're going to leverage the command gateway. The command gateway is a convenience method compared to the command bus to publish commands in an Axon application. So on there, we got a couple of ways to publish commands. We got to send. Got to send with a callback so that you can react on a success or a failure, and you can do a blocking send by doing a send and wait. So that the result is that you get immediately, so you get the exception in your face if you want that.
Cool.
For now, we're going to deal with just regular send, like so, Stephen. Yes. We're going to create a wallet. We need an ID in there. I think UIDs are a good thing to do that, and we start off with 1,000. All right. We need to do this.
So we've got our wallet created by this step.
Yes.
And then are we going to put some deposits in and some withdrawals as well?
Yes, definitely. Let's do some deposits, show it off. That's why I removed the wallet ID as a field. We're going to introduce 42.
So we're just simulating what a regular client would do. I mean, obviously we're not building out a UI or anything, but...
No, definitely not. So here we go. And this is actually something I should be able to test. So let's start it off.
Oh, cool.
Let's see what this does.
Yeah. So we'll just let Spring Boot do its thing, right?
Yes, definitely. So let's move the package there. So this should be visible. Application is starting up. All right, application started. Let's actually do a curl operation there. So curl -x get local host default port, and I'm going to do command. So this is fair because we did a void, so we do not expect anything on this point. So let's go back to our terminal. And we got some warnings in there. And I did this on purpose because this is quite important to show. So we had several commands, and some of those commands need to target an existing aggregate. But we didn't tell Axon how to or what ID in your message is going to target the existing aggregate. So that means that the creation just introduces a new one, so you do not target an existing one. But the deposits go to an existing wallet. So we need to tell Axon that these wallet IDs are the fields which reference the target aggregate identifier you're looking for.
So you're targeting a specific instance of an aggregate, which is different to how you would work in CRUD, for example.
Definitely,
right.
definitely.
Okay.
And I think it would be nice to actually show some logging going through.
Yeah,
so I'm going to use the callback mechanism to introduce a logging callback. So this is baked into Axon, that you automatically have a way to log a command being successfully or failure. And I'm going to do a similar thing for events, because it's nice to see our events going through the system as well. Going to introduce a very pragmatic event logger, and this is also cheat sheeted, so I can share a couple of things about this. So you can see this is a regular Spring Bean, just a component. We got a logger in there, and that's being called in our event handler. So this is somewhat similar to our command and event sourcing handler annotations we have, but this just handles any event going through. This is not to source the state.
So it's kind of like a listener, I guess. It's just listening out for any event messages that are happening and reacting to those as they happen.
Yeah, correct, Ben. And there's one funny thing I want to note here is that the parameter I get here is the object. As you might have seen from the other message handling functions we just had, I took the create wallet command or the wallet created event, very specific the messages I created. What Axon does for events is that it will look for the most specific implementation of the event coming through. And as this class doesn't have any event handlers for the wallet created event or the deposit or the withdraw, object is the most specific event coming through. It's the most specific class implementation.
So for now, it's a kind of convenient catch-all. We can just catch all events going through the system.
Yes, so it's a convenient way to show all the messages going through.
Okay.
Actually starting it up.
Ah, terrific.
So see that going through, and I believe this is being started up. So I can do this again. We expect nothing again because we do a void. Let's go back, and success. We got our commands and our events going through. I'm happy with this. I think we're done with our command model at this point, Ben.
Yeah, that's good. So, so out of seekeres, we're halfway through. So, should we do some query stuff then?
let's introduce our query model as a package, because we're clean coders, and we want to separate our application later on into separate components. And as as I showed on the CQRS diagram, the query side reacts on events in this scenario. So we're going to introduce an event handler to create a wallet query model. Very simple query model, but for now it'll do, just to show off how this works. So a regular event handler with a typo, which is okay. We make it a component, just as our event logger, so that Axon knows, as it's in a Spring environment, I need to look for all the Spring beans to check whether there might be message handling functions on them, like command, like events, like queries, stuff like that. And we're going to introduce an event handler for the wallet created event. That's what we're going to do. Now, this is cool, but we do not really have the dedicated query model yet. No. So we need to create our query model too. And in this scenario, it's just going to be a simple projection of an existing wallet in our system. I'm going to introduce another Kotlin file, which I'm going to call the query model, with a typo again. Wallet query model. I did this live template as well because I expected you guys didn't want to see me create an entity, just the APA stuff, not too exciting. And I got my repository in there as well, because we need to store and fetch the wallet view we're going to create.
And people call these different things, don't they? So some people call them a projection, some people might call them a materialized view. There's different terms for these, but essentially it's a rendering of some of the information that's been flowing through the events, right?
Completely right. Yes, completely right. So now we can go back to our wallet event handler, and we introduce the wallet repository like so. And we make it a constructor, and we do save, because we're going to introduce a new wallet view. And we're going to pull out the wallet ID and the balance. And this is now our synchronizing bit in the application. This is the way to synchronize our command and query side. This is dumb. Well, we haven't introduced a way to actually query this wallet yet. So we need to introduce another form of message, the query message. So I'm going back to our wallet API, because it's part about the public API we're going to share with other people who want to access our wallet. Going down to our class.
So again, the semantics are very clear here then. This is a query for a specific thing.
Yes, right. Yes. And I'm going to make this a find all wallets query. Very simple. I just want to return all the wallets which are in existence in our application. So I copy this over, and I go back to our wallet event handler, because the one who's going to answer this query should, in my view, be the one who can best answer the query. And somebody who can answer the wallet views which are in existence best is this wallet event handler, because it is updating the wallet view. So we're going to introduce another thing, the wallet query handler. And this is, again, quite similar to our command and event handler or the event sourcing handler, just another more specific format of a message with the different routing capabilities which we discussed earlier. So we're going to just do a find all. So we do not need any parameters in our query in this scenario. It's just notifying that this is it. And we're going to return it. Make IntelliJ help us. So we got that. And we're missing one thing here, Ben. And I think that we need a way to actually query this through our REST endpoint as well.
Of course, yeah.
So let's introduce another thing, the wallet query controller. And just as with the command controller, I didn't want to bother you with seeing how this is created. And there's a typo because I typed it, rename file, sure. Okay, and we actually need a way to publish a query now. We have seen how to publish a command through the command gateway. We've seen how to do that from an event in an aggregate. And for the command side of things or query side of things is quite similar to publishing commands. It's just we have a query gateway and a query bus. Query gateway being convenience method, simplifying your will to actually send the query. So we're going to introduce a query gateway like so. And we're going to add this constructor parameter. And there are several ways to send the query. There's just a direct query. There's a scatter-gather query. And we can subscribe to results in a query gateway as well. But for this example, we're just going to do a direct query because there's a single source who knows best which wallets exist. It's going to do a regular one. And we need to have the find all wallets query, like so. And make it so. And we need to tell Axon what the expected response type in this scenario is. And we're expecting a list of the wallet view. So what we're going to do is response types, which is a static thing in Axon. We can tell it to do a multiple instances of or a single instance of. We're going to do multiple because we expect a wallet view list. And this is actually, I think we're done on our query side, Ben.
Wow, cool.
This is the very basics of separating a wallet application into a command and a query side with a dedicated core API, which we can share with other people to access our application. And it's already started up. Let's see it actually work. So we go back to our commander and we try this. We still see our events and commands going through, so that's happy state.
So that's initialized our wallet. It's got some cash in there. There's been a withdrawal and a deposit, right?
Yes, and we actually see our wallets coming back too. And what we should be able to do now is actually send a couple of commands to create more wallets and actually see them on our query side. And I think it does that, right? So I shouldn't have done that. That's fair. But Ben, I think we've got an amazing application here.
Okay.
Let's actually make this a live thing, right?
Let's get into production.
Yeah.
Right. So if you don't mind me using my fudgy fingers on your lovely keyboard,
That's completely fair,
we can push this to PCF, right? So if I do mvn clean install just to make sure we're completely ready. Boom, and then if I draw your attention to the screen over on the far right there, what you can see is a PCF manifest. Now, manifest PCF is a tiny file, just gives you a little bit of information about the application that we're about to send there. But what you'll notice is that you used a database, right?
Yes, correct.
But when you were working locally, you were on H2, I think it was?
Yeah,
okay, so when we push this out there, though, we want a regular database, right?
Oh, yeah, I forgot that dependency.
That's okay. PCF can handle that.
Oh,
so all I need to do is create myself a service. So I'm not going to get on the phone to the DBAs. I'm going to do it myself.
All right.
So I'm going to do cf create service. And I already happen to know that in the marketplace for PWS, there's a MySQL database, so I presume that will work.
Yeah, that should work. That should be
That's called ClearDB. And they have a free tier because we're working on a budget, right?
Just development time right now.
Their free tier is called Spark, and I'll just call it MySQL because I'm going to get them named to match that manifest up there. So there we go. Oh no, failed.
What's it doing? Error performing request.
If you were behind a firewall, I'm not behind a firewall. I tried this earlier. Right, so let's try it one more time.
Okay, we're lucky. Demo gods, right?
Demo gods definitely looking at me being a bit mean. Yes. So what's he doing in the background there? So creating a service in PCF, it uses a service broker, and that's an international standard now as part of the CNCF. So that is going to go away and create a table space for me. It's going to give me some room in that database dedicated just to my application. And then when I push the application, it's going to bind that database to the application. So I'll talk about that while it's doing the push. So if I do now just a simple CF push, then it's going to take my jar, the jar that you produced, which is a fat jar. It's going to push that, the wallet application, of course. It's going to push that to PCF, which is what you're observing there. In fact, I can tail the lock here.
That would be interesting.
For the wallet as well, to have a look at what's going on. But in the background there, it's doing the bind now. So it's taking the database and it's creating me a user. And it's getting some creds for that user. And it's attaching all of that to a container, which it's currently building in the background. That container will get a whole bunch of environment properties. It'll also be added to my load balancer. It's going to get a route so that people can attach to it from the outside world. It's going to do loads of things in the background, including telling me how many instances. We got this firewall again. This demo god is not happy today, is he? Because parts of it look like it worked. So I'll do it again. Please, demo god.
Oh, mapping routes is already doing more.
Yeah, that's okay.
Yes, and we see logs on the right. Okay.
So it's doing something, but I think the network is occasionally panning us, but not to worry. So it's doing lots of stuff in the background, and that's the thing about PCF. It's highly productive for developers. I did that just by typing at the keyboard. I could have automated that. I could have scripts that do that. And it's also taking care of issues that we didn't perhaps anticipate. You said, for example, you forgot to add a database driver, right? So what you can see there, if I can find the clicker, is where is that? Around about
Oh,
here.
really? Yeah,
There,
yeah.
it's actually adding a database driver for us as we forgot to do that.
That's so
So
nice.
that's pretty clever, right?
Yeah, that's super fast.
The fact that we get a route from the outside world and it's load balanced as well means there's no ingress or egress to configure. I don't have to go and manually sort out networks and routes and DNS entries and all that sort of stuff.
That's so fast.
It's just happening in the background.
Yeah, yeah.
So in a moment it'll be finished. Database should be bound, and here we go. Right, so we're ready.
So can we actually hit our application now? It should be live, right?
We can. So we can use similar curls to what you did. So if I do curl minus, where is it? Minus X. Sorry, different keyboard.
Yes, I'm sorry for that.
No, it's all right. Wallet dot cfapps.io, and then as for command, was it?
/ command should publish a command. Yes. So
okay.
if we do that.
So we're still tailing the logs, remember? So you can see
yeah.
there it's handling all that stuff to do with issuing the command, and then I should be able to query it, right?
Yeah.
So if I do query / wallets.
Yeah, to give all the wallets.
Let's have a look. And there's all my wallets. So
nice.
that's good, right?
Nice, sweet. That was so fast. Great. All right. So if I publish more commands so that we create more, do we get more in our wallets? So see the logs going through, yes. So now I got even more. Yeah, it's even bigger. Sweet.
It's good, right?
Great stuff, man.
Okay.
So
it's done.
So we share why we have actually shown this.
Yes,
this
we
is
should.
Super cool, but this wasn't. We started off with the Axon Trader, of course, and that was one of the reasons. We can jump these, right?
Yeah, we can jump these. I've talked about these already. Yes. So how does this help us, right? So there's a bit of overhead, particularly cognitive overhead, with trying to understand CQRS and then to apply it. But why would you do that? What does it help us with? So what we wanted to achieve with the Axon Trader, which I showed you right at the start there, was a practical example of an evolutionary architecture. So that's what we went and built. So when we started to build the trader, we built a monolith. And we started to understand all the different domains that are related to that monolith, things like the companies that we wanted to trade on, the users, the portfolios that they might own, how the order book might work, and we coded all that into one monolith.
Yeah, just one single package, just like we did with our wallet just now.
Exactly, which was really easy to build, and we only needed a database service, and it was very straightforward, right? But it's not easy to maintain, and it's not easy to scale. So we then leveraged that approach by using location transparency. So because the events, for example, are things that can be transported from VM to VM, we could, by adding services, allow that transport to happen and migrate pieces of functionality out into more microservices.
Yes. So our commands and the queries and events, because our API is that, we could just have our components in several places, several different services if we wanted to, and just bind them with the services you added through.
Exactly, and that's precisely what we did. So we moved out the trading engine that you can see up there. Used to be part of the original trading application, but we just split them apart really easily. And that gave us lots of benefits, including being able to maintain it easier, but also being able to scale it differently. So as stuff needed more computational power or needed more resources, then we could give it more scale or reduce that if we didn't need that so much.
Yes.
And the PCF marketplace made that really easy, right? We could just go in there and cherry pick from those services and reuse them in our applications. So we had Rabbit, for example, helping us to migrate messages from one place to another, and we used Spring Cloud Registry as well, didn't we, for some of the command gateway stuff.
To register where every command was or query was.
Exactly. So you could issue a command and it would be routed to the right component to deal with that particular command. And the component itself was transparent to it. It was unaware that was happening, right? So that's why we did it.
Yes.
We didn't do it, just for fun. It was also there was a
it was great fun.
It was great
I really
fun.
liked it.
But there was also a practical reason for it, which was that we could experiment with this location transparency and this evolutionary architecture, and then utilize the cloud better.
Yes, definitely.
Right.
Yes. So, and there's one final takeaway we want to give on this. So, what would be next after what we just did? We have shown you how we do this in a virtual wallet, and we've shown that that is what we did with the Axon Trader as well. What is very nice, I think, is those services could all eventually be replaced by adding something like Axon Server. So Axon Server is a product we at AxonIQ are working on, which is a dedicated way of routing your commands, events, and queries, and is also a dedicated event store for you, which should be more sufficient than a MySQL approach. And this is a thing that we can share. That's a thing we are very likely going to work on to get this to the marketplace of PCF. And doing this will allow you to, if we go back to the previous slide here, we had Rabbit and the registry stuff and MySQL for our events. Those could already be replaced by just having an Axon Server instance in there, doing the dedicated routing for you. I do also want to know that Axon Server is, by the way, open source, so you could just play with it if you want. The easiest way to do that is with doing the latest version of Axon, being Axon 4.
So with that, I think we're roughly finished.
Yes.
So we have a little bit of time remaining. Maybe we could take some questions. I think I've got a mic available to me if anyone's got any. So raise your hand if you go on. I see one over here.
Yes.
Oh, can I get that way? I think
Yes,
you
you
can.
can.
That way. Oh, yeah, okay. All right. My friend.
Hi, thanks for the talk. I just wondered how dependent this framework is on Spring. If you use something like Juice as a dependency.
You could do it without Spring. So there is a dedicated Axon Spring module to simplify it in a Spring world, and we also have the Spring Boot starter, which I just shown. You're not required to use any of that. We also have a CDI module we're working on, so if you're in the EE world and you want to use that, that's also a possibility for you. Yes. Oh. I'm also okay with running, Ben, if that's easier.
No, it's fine. Be even funnier if I take a dive.
Hi, I have a question. You were working with MySQL right now, but is it also possible to use a NoSQL like MongoDB or something instead? Yes. Because I tried it earlier. I don't know on which version of Axon, but that was very hard to do.
Oh, yeah. So we currently there are a couple of ways to have an event storage engine. That's the internal bit. So there's a JPA, JDBC, and a Mongo version of that. So if you want to use Mongo, that's an option. We have moved that as being an extension because it's a very separate thing from what Axon Server does, because Axon Server is also a dedicated way of storing your events, also in a NoSQL way.
Do we have any more questions? I'm quite prepared to even run at the back.
Do you want me to run?
No, it's good. Oh, hang on.
No, just another one. Let's go.
We've got a follow-on. This is the most fun bit. Can we just do one talk just doing this? Sorry, carry on.
Sorry about that.
No, that's fine.
So if you have, how easy is it to optimize for whatever particular database is backing it? If you have queries, for example, that are optimized for Oracle or MySQL or whatever.
So what the Axon Framework allows you to do is to separate that command and query side of things, right? So that you can optimize the database you want in the different way you need to answer the queries you have. So that might be the projection we just shown, but maybe you want to do a string search or text search like Elasticsearch. So you could just introduce an Elasticsearch instance and listen to the events and populate that. But the optimization on the query side of things, the query world, is really up to you. That's the thing that enables it.
And on that point, don't forget of all the good stuff that you've already got in Spring around Spring Data. So you've got all the JPA support, you've got optimizations with dialects in there, and then there's R2BC, I think it's called, which is a recent innovation to do with using JDBC more directly. So there's lots and lots of cover in Spring generally for dealing with projections and for optimizing those things as well.
Yes.
Do we have any more questions? Oh, we do. Excellent. How do we have time?
Going to be top fit after this, Ben.
How is concurrency handled, especially in terms of like concurrent commands towards the same aggregate?
Yeah.
And especially if you've got multiple instances of your application.
Yes. So on the default approach, if you use the regular command bus in there, that will give you a simple command bus. You can change it to an asynchronous one that you can send more commands, but you need a way to lock that aggregate that nobody can access it whilst an operation is being occurred on it. So for that, there's the aggregate is retrieved from a repository, and we now show that through event sourcing. So there's an event sourcing repository behind that, but there's a lock placed on the wallet on this aggregate in this fashion, so that there's a blocking way to the following command being executed on it. What you can also do, there's a disruptor command bus, which separates the publishing of command, handling of commands, and the handling of the events in the event sourcing way, so that you can be even more faster than that on it. But that's a thing I don't have time for you to show right now.
Any more questions? No? Okay, so just
believe
before...
someone, you
Oh, is there?
No, I'm joking.
Okay.
Just sit down.
No, okay, nice work.
All right.
So just before we finish then, so up on the screen there, you can see QR code to go and visit Axon Trader. So we told you about that at the start, but please go along and have a look and dig into the code. It's much more complex than the wallet that we showed today.
Definitely,
It's got more... much more meat in there, if you like. And then over on the right-hand side, there's the wallet repo. So that's the code that we've produced today.
Yeah.
And feel free to get in touch.
Yes.
Twitter details, email, whatever.
Yeah, if there are any questions about Axon Server, you want to talk about it, please just email me. I'm kind of inquired to share this with you. There's another thing I want to share. So next week, I'm providing a training over in Utrecht in the Netherlands about the Axon Framework, a 2-day training. And I can give away a couple of discount codes. So if you're really interested and you're in the vicinity,
come ask for a code.
Yes.
All right. With that, I think we're done.
Yes. Thank you for listening.
Thanks, everybody. Cheers.